Oh, you guys are back. Awesome. You guys want to dive into 10.2 with me? More circle geometry here? Sounds good. Exploring chord properties. So we're going to look at in this section another rule for circles having to do with perpendicular bisectors. So we'll look at that on the next page when we start looking at the chords. But we do need to know what it means to bisect something. So when you bisect a line, bisect, it means you're cutting it perfectly in half. So you're leaving both sides the exact same. So that's going to be important in our next rule. So we learned two rules in 10.1, and so now we add a third rule. Okay, so the perpendicular bisector of a chord rule. Okay, so a line that passes through the center of the circle and is perpendicular to a chord bisects the chord. And this is going to be pretty important for a lot of problem solving questions here in this chapter. So a line that passes through the center of the circle. So if I just draw a line that passes through the center of the circle, we all know what this line would be called, right? It's called the diameter, right? So any line that passes through the middle of the circle is the diameter. Okay, and if that line is cutting perpendicular to the chord, it means it bisects the chord. So if I take a chord that is perpendicular, or in other words, at 90 degrees to this line that's cutting through the middle of the circle, it means that it will bisect the chord. So in other words, if I do that, this is going to be cut in half. This side will be equal to this side, if you ever do that. Okay, so on here on this picture, I could do the same thing, cut it here. If that's at a 90-degree angle, then that means these are going to be perpendicular. With this, both things are true. If you say if it's perpendicular, it will bisect, then I also know that if I bisect, that means this is a 90-degree angle, and that's often what we'll use to set these some of these questions up in this section. Okay, so example 1 here. This is where we're going to use this rule. So radius CD, so this is the radius of the circle because it's cutting from the middle. It bisects the chord. Okay, so because it bisects it, that means these two are the same, which based on our rule, that means that this must be a 90-degree angle. You may already be able to see where this is going, because if I just created a right angle, I have a right angle triangle, and so we know a certain theorem we can use with right angle triangles. Okay, so chord AB measures 8. So if this from here to here is 8, that means this has to be 4 and this has to be 4, because it bisects it, it cuts it in half. And then the radius of the circle is 5. So if we look at this, this is 5 from here to here, but this is also the radius from here to here. Anywhere from the middle to the outside is also 5. Okay, so what's the length of CE? So from C to E. Well, if I just take this triangle out, right, and I make this 5 and this 4, I can figure out that side length. So Pythagorean theorem. We've got one of the legs here, so it's going to be 5 squared minus 4 squared. Okay, so it's 25 minus 16, which is 9. So this would be 3. Okay, and you might notice 3, 4, 5, that's our standard example of a Pythagorean theorem. Another type of question we could be asked for is what's this? What's this side length? So if this is 3 and the whole thing is the radius, which is 5, we could actually figure that out as well. You'll be asked that in certain questions. Okay. We'll go through the show you know here for the next one. Similar type example, although we might be given certain different ones. So the radius CH bisects. So here, this is bisecting. So I show that on there. The chord FG measures 12. So from here to here is 12, which means this has to be 6 and this has to be 6. Okay, the radius is 10. So again, this is 10, but also this is 10. And going back to our rule, I know this is a right angle triangle. Okay, what's the length of CJ? Okay, and so Pythagorean theorem. This is 10 and this is 6. I can find that side length by doing 10 squared minus 6 squared. Notice it's the subtraction one because we're missing one of the legs. So it's 100 minus 36, so it's going to be 64. Okay, so from there to there is 64, and is 8. So the picture doesn't really show because it looks like it's almost half. Where this is 10, that would mean this is 8 and this is 2. So don't always judge by the picture. Just do the math behind it. Okay. Example 2 is not going to be really practical for this section, but it's kind of just using the rule that we just learned, and basically it gives you a way to figure out the middle of a circle. So if you took a chord and you went at a 90 degree, if you cut it in half first of all, and then you went at a 90 degree angle, right? So you know you've cut it in half, so if you measured this out and did that, and then you did that from somewhere else on the circle, and you did it over here, so you took another chord, you measured halfway, let's say, so this is the same as this, and you measured at a 90 degree angle, right angle. These two lines would cross somewhere, and what this example is showing you is that they're always going to cross right in the middle. So if you did it over here, you made a straight line, you did it over here, you did a straight line, you could do it again, you'd get a straight line, and they would all meet in one certain point, or they should if you did it correctly. And so that point is going to be the middle of the table. So you're not going to really be asked for this on a quiz or anything. You'll just be asked to maybe explain how you could find the middle of a table or the middle of a circle by doing that. Okay? So just a few questions to practice on page 389.